Alright, time for the math. Easy. So we're going to discuss further into limits at infinity and look at horizontal asymptotes and go over some examples. Now, you can do part 2 of this video series. In an earlier video, I went over part 1. You can see that, and you can see that in the video link below. Basically, I have 3 examples right here. They're pretty useful. I'm just going to go over these pretty quickly. I'll go over example 1 first. Basically says find infinite limits and limits at infinity and asymptotes for the function below. So if we look at this one, let's just call this f of x right here. And now let's just look at the infinite limits first, or the vertical asymptotes. Yeah, so if we look at this function right here, I drew this roughly, so just assume these are like straight lines, kind of approaching straight lines here. So if we look at this one right here, the infinite limits where it goes to infinity here, and on this case right here, let's just start on this one first. As we're approaching -1 from the left side or from the right side, as you can clearly see, it's going to go to infinity right here, just getting really high. And similarly for this case here, as you're approaching 2 from the left side, let's call this from 2, this minus sign on top, or negative sign, meaning from the left side we're going to be going down to negative infinity. And similarly, if we approach from the right side or the 2 plus side, we're going to go up to positive infinity right here. And we could write these limits as limit as x approaches, well, the first one, -1 of f of x, this equals to infinity right here. And then similarly for the other one, we're going to write limit as x approaches, well, 2 from the left side, or this negative sign, of f of x equals to negative infinity. And similarly we're going to have basically limit as x approaches 2 from the right side of f of x equals to positive or plus infinity right here. And now from this we know that the x equals to -1 and 2, basically these vertical lines are vertical asymptotes right here, and we can write that down. Yeah, so I just wrote that down right here. So now let's look at limits at infinity, or moving towards infinity, or positive and negative infinity. In other words, horizontal asymptotes. So as we're approaching, in this case, the negative infinity, as you can see, we're approaching a limit right here, and this 2 line is y equals 2, and this is a horizontal asymptote. And when we approach positive infinity, or just infinity, as you can see, we are approaching this horizontal asymptote, or limit of this 4 here. So we could write these limits as limit as x approaches negative infinity of f of x is equal to, well, this one's just 2. And then the other one, we're going to have limit as x approaches positive infinity of f of x, this equals to 4. So from this we know that y equals 2 and 4 lines, so these 2 lines, notice that it's y equals this, that's a horizontal line, and x equals these are vertical lines. So this is going to be a horizontal asymptotes right here. Yeah, and basically we've answered the first example, first question. So now let's look at the second question. Yeah, so now if we look at example 2 right here, this one states find the limit as x approaches infinity of 3x squared minus x minus 2, all divided by 5x squared plus 4x plus 1. So now before we solve this limit, let's just see what happens when we plug in really large numbers. Well, if you look at this one right here, this x squared, if you put in a large number, this x squared is going to be bigger than this x. So you're eventually going to go to infinity right here as you put really large numbers, and the same for the bottom, you're going to go to infinity. So we're going to get a form of, let's say, infinity over infinity here, and we don't know what the limit is going to be. If it's going to keep going to infinity, maybe this is higher, maybe this is higher, etc. And then maybe it's basically like a fight between the top and bottom to see what will happen, if there's going to be a limit or not. And now to solve this, we could apply L'Hopital's rule, and I'll just write that down. So we could apply L'Hopital's rule. I've gone over it. You can see in the video link below, where we could basically find the limit of the derivatives of the top and bottom. It's a bit more complicated, but you could do it pretty straightforward. Or if you haven't done this, we could do this other method's pretty easy to follow, divide by highest power method. And this one, what we could do is basically divide both top and bottom by the highest power, in this case x squared. Yeah, so let's write that down right here. So let's just follow this divide by highest power method. So we could just go 1 divided by x squared, so we multiply the top, and then bottom 1 divided by x squared. And we're not really changing the value, because these ones just multiply or cancel out, become 1, so you're not changing the values. So now when we have this, we could divide each single value by x squared right here. and this would equal to limit as x approaches infinity of 3x squared divided by x squared minus x over x squared minus 2 over x squared. And similarly for the bottom, for the bottom we'll divide each single one by each single number here by x squared right here. So now these ones cancel, so these cancel, and this cancels, etc. And this one remains the same, and we're going to be left with now limit as x approaches infinity of 3 minus, this is going to be 1 over x minus 2 over x squared. And similarly for the bottom, the bottom is going to be 5 plus 4 divided by x plus 1 divided by x squared right here. So now if we apply, now we could basically plug in really large numbers or infinity, and basically each one of these terms with the x's you're dividing by a really large number, so they're all going to be approaching 0 right here. So it's approaching 0, this is approaching 0, etc. So we're just going to be left with then 3 over 5, basically minus 0 plus, this is a plus 0 on the bottom, or just equals to 3 over 5. So this is our limit right here, and this is our horizontal asymptote, and that's our answer. So now let's look at example example 3 right over here. Okay, so now if we look at example 3, this states find the limit as x approaches infinity of this square root x squared plus 1 minus x function. So now this one, if we just try to put really large numbers, as you see, this one's going to get really large. So, and then this as well is going to get really large, and we don't know if they're going to have some sort of limit where they basically, when you subtract it equals a limit or it goes to infinity, etc. We don't know what's going to happen, so we can't really find a limit just by this function. So we have to simplify this a bit further, and we could do this by rationalizing denominator or multiplying by conjugates. And I've just basically written this down. We could simplify by multiplying by conjugate, or you can see my rationalizing the denominator video in the description below where I go over that. It's pretty straightforward. In this case, we're going to multiply this by, well, this plus x. So let's write that down, and we'll just write that down right here. Basically we'll have this limit x squared plus 1 squared minus x multiplied now by the conjugate, or the same thing, go with a plus of the on top and bottom, so we're not changing this function because this is just equals to 1, where they just cancel out. So when we have this, now if we basically expand out the top, we're gonna get something like this right here, limit as x approaches infinity of, now from the top and bottom, let's write the bottom first. This one is square root x plus 1 plus x. And now the bottom's gonna be, the top's gonna be, when we multiply this side by just basically the FOIL method, we're gonna get x squared plus 1. This is this multiplied by this, and then basically this multiplied by this one right here, plus square root x squared plus 1, and also minus, now we're gonna multiply this by this, and this by the x one all the way over there. So we're gonna get minus x squared plus 1, and the reason we're multiplying by conjugates is exactly because these two will cancel out, and the last one's just going to be negative x squared right here, so negative x times plus x, and now these cancel out, it'll be 0, and we're left with, so we're left with this function right here, this x squared plus 1 minus x squared. Now this cancels out, so we're going to be simplifying it even further to limit as x approaches infinity of this one right here, so square root x squared plus 1 plus x right here. So again, we can't really divide this out. No, actually, you can divide this out. In my calculus book, it goes further than this step, and it divides it by the highest power. In this case, it's going to be this x, because remember, x squared, square root of x squared is going to be x. So it divides x on both sides, and it gets basically 0. But this, we could just stop right here. And this one, as you put infinity into the bottom, we're going to get basically a really large number here. So we're going to have this equals to, well, 1 divided by, well, basically this is going to be a large number. Let's just say infinity squared plus 1, and this plus infinity and everything. So the bottom is going to be really high, so it's really large, or 1 divided by infinity. So this is approaching 0. So we have a horizontal asymptote at 0, and that's our limit. Well, that's all for today. That's our answer for question 3. That's all for today. Remember, you can download these notes in the Dropbox link below, and yeah, make sure to watch the related videos in the video links below in the description for more information on videos that relate to this. Well, that's all for today, and stay tuned for another math easy solution.